I would like everybody in the class to imagine and just close your eyes. Trey! I said close your eyes, Trey!
He never listens to directions.
Okay, so now with your eyes closed, Trey, I would like you to picture the blue sky in this video, but picture it as a black sky. Every cloud is actually a star, and the sun is actually the moon, because although it looks daytime, it is actually nighttime. Now prepare to embark on the journey that is the physics of sneaking out.
I need you to get these dishes done right this minute. You are not to leave this house until the dishes are done. You got it?
Well, golly, I sure am darn tootin' mad I didn't get to go to the party. Let's check Snapchat. Look at the Snapchat I got of the party. Yeah!
Wow, this party's gonna be great. I better go wake Jack up so he can come along. I wonder what makes my rocks hit his window. Let's go analyze it at the lab.
The physics concept behind this is projectile motion. A projectile is an object launched into the air where the only force acted upon it is gravity. There are two concepts of its motion, which are vertical and horizontal. Vertical acceleration is the acceleration of gravity, which is negative 9.8066 meters per second squared, while horizontal acceleration is 0 meters per second squared. This means that you must account for the parabolic trajectories that your projectile will take in the air. This is why Michaela couldn't aim directly at her target, because then she would have fell short, following the parabolic path. Instead, she had to aim a little higher than the target, so it would come down and eventually hit its target, which was Jack's window, which got his attention.
What do you want, Michaela?
I'm here to freak you out. Come to this party.
Alright, I have to sneak out though.
Okay.
I wonder what the physics are of me sneaking out. Let's go to the lab.
When I was tiptoeing, I want to make sure that I minimize the sound that I make so as I don't wake my parents up, which minimizing sound would mean minimizing radiant energy since that's what sound is. Also, I can utilize impulse because I want my force to be less. So that means I can have a shorter force over a longer time to get to the same impulse, which therefore will minimize the radiant energy resulting from that force.
I wonder what the physics involved were with opening that window. Let's go analyze it to find out.
When I was opening the window, I know that Newton's second law applies, and that's the law of acceleration, which states that force equals mass times acceleration. So that means the window has a certain mass, and I'd like to accelerate it upwards, so I have to apply a force that would equal that. However, I also have to apply a greater force than that because it also has to overcome the force of friction.
Do you see that form? Let's go check that baby out in the lab.
When I jumped off the roof, at the very top I had gravitational potential energy. There's another type of potential energy, known as elastic, but we're not going to talk about that right now. To solve this equation, we needed 3 different variables for potential energy. So we measured my weight, which we then converted to mass. We also measured the distance, which was the displacement from the top of the roof to the ground. And then also the force of, the acceleration that gravity had on me was negative 9.8066 meters per second squared. So we made potential energy equal kinetic energy at the very bottom, so that way we could find out what my velocity was right before I hit the ground. So when we solved this, mass ended up canceling out, showing that mass doesn't affect something in free fall. And then once we solved it, we found that I was going 6.92 meters per second right before I hit the ground.
That applies to Jack jumping off the roof is momentum, which is caused by a force exerted over a time. So when he lands, he has to bend his knees to extend the time. Because a big force over a short time is the same as a small force over a long time, so that he doesn't break his legs, he needs to make the time longer so that the force is smaller.
I got out. Now let's go to the party. I have to sneak out of my house, so I'm gonna try and limit the noise. I'm gonna put it in neutral and not step on the gas.
Drink, so now I have to pull her back to bed. I wonder what physics were involved with pulling her.
The concept that Jack had to use when dragging Michaela across the floor was friction, which is the force that opposes the movement of an object. So, as you can see in the diagram, normal force was acting on Michaela and her weight was dragging her down. But the force of friction was the opposite way that Jack was pulling because he had to overcome that force. And here's his force applied, which is what he had to exert in order to move Michaela across the floor.
Just a little disclaimer before I go take a dip in the pool. After Jack dragged me into his bedroom, nothing bad actually happened to me. He treated me like a perfect gentleman and he was a very good friend. Also, Isaiah and I did not actually consume alcohol to make this video, it was just water. The end.